Good morning, good afternoon, or good evening. My name is Watralin. You can call me Lex. Today I'm going to demonstrate you about my project blockchain stimulation, which is called dBlind. As you can see, let's assume you already know about what is blockchain, what is private blockchain, and what is public blockchain. So first of all, the blockchain simulation provides concept in blockchain technology using the consensus algorithm, proof of elapsed time, to validate transactions in the simulation. So I also assume you already know what is proof of elapsed time. If you don't know, you can do a little bit research about that consensus algorithm or that consensus mechanism. So in this project, the technology stack and tool that I use is, first of all, React. The second one is Next.js. The third one is Redux for the state management, JavaScript and TypeScript. Google Cloud Platform for the Firebase. For instance, I use Firestore, Firebase Cloud Function, or Google Cloud Platform Cloud Function. And for styling, I use Sass, Bootstrap, and the Crypto.js to do the cryptographic hash algorithm, and Node.js. And I host the Node as the instance in the AWS EC2. So without further ado, we're going to go to the slide. So in this project, it's called dBlind Blockchain Simulation with PoET. So I assume you already know everything about this. So when it comes to consensus algorithm, proof of elapsed time is very common consensus algorithm used in the blockchain technology network. So this one is mostly used in the private blockchain or permissioned blockchain. So as the definition of this proof of elapsed time is, as each participant node in the blockchain network will receive a waiting time and its randomly timed duration. The very first one that has completed the given waiting time will be able to add a new block. So it's like a countdown, the given random time, and the one that has less or minimum time will be the one who will be able to complete the transaction and add it to the block. So we have three platforms in here. The first one is called dBlind Apps. It's written in TypeScript using React.js for client-side application. So this one will be the user side that will be used to interact. The second one is called dBlind Cloud. It's written in TypeScript using Node 12 as the cloud functions to be a middleware or a network protocol to prevent deleting, editing, or invalid transactions into the database. Additionally, it is the one who fetches transactions from pools and generates random time into each node to add blocks. The third one is called dBlind Service Node. You can call it a node also. It's written in TypeScript using Next.js as a web service to facilitate as a node to participate in the private blockchain simulation. So this one is this dBlind service will be, we will have three instances that will run in different server. So this one are the one who handle the network protocol. Okay, will be the one who, as I mentioned, will be the one who handle the network protocol simultaneously with the cloud function accordingly together. So our processes are simple. The first one, the customers can make a payment to another customer, then all transactions will be added into the network pools. The cloud function, also known as the network protocol, will get the earliest transaction within the pool and generate the transaction into the queue. Then it will take all the nodes within the network to continue the work by giving them generate random times. Web service facilitates as the node will listen in real time and pick the very first queue as it has. The very node with the smallest amount of time will complete the adding blocks and distribute them across the network. When a node has completed its task, it marks that specific queue as is completed. Then other nodes, while countdown for its task, will hold everything and prepare to receive the next task within the network by listening to the next queue. Fifth, during the distribution, each node will check the received transactions themselves and only receive the validated transaction into their nodes. If any node has missing blocks of transactions, it will reinstate itself back by pulling the missing blocks of the transaction from the network. Moreover, verify those blocks by checking the block hash value. 7th, since it is a private blockchain simulation, database is centralized and decentralized storage. Cloud function will handle all the procedures like preventing data tampered with the data deletion and the data deletion. Suppose any block or transaction information is being deleted. In that case, the cloud functions will reinstate the data back. Or if the data is being modified, it will reinstate the previous one that matches the hash value of a block. 8. And each node that stores data as distribution will not take the modified block or transition into itself. Moreover, it will delete invalid blocks automatically. So these are the data model, block, and transition. And we have these are all the main attributes of the blockchain that we have to complete. Partial peer-to-peer, as I mentioned. We have centralized and decentralized storage because it is a private blockchain. Distributed, cryptographical secure, add-only, consensus, that, as I already mentioned, consensus, proof of elapsed time. So let's start with the feature that we have in here, blocks, data table visualization, and the second one is like make payment to other customers via address. Okay, let's start with the demonstration. Okay, as you can see that we have 2 instances running. So these 2 instances are running differently. It's not the same instance. And okay, right now you can see that you have 3 nodes. The first node is called Zeus. This one runs on localhost. And the second one is called Apollo, run on EC2. The third one is called Babylon, run on EC2. So these are 3 different nodes that run on different instances. So as you can see, it's not the same machine, and I don't know which one will be the one who validates the transitions and add them into the block. As you can see. Okay, let's go to our app. So I will be sign out and sign in as Tommy. And I will check his amount. So his amount only like 101 and 500. 101k and 500. So this is his address. I'm gonna copy it. Copy it like this. And I sign out. I go to Lex, my account. And I want to make a transaction to Tommy. And I just paste that address. How much do I want to make? 1,000. For what? Maybe food. You can see I put food and enter the message maybe for burger, American cheeseburger. I don't know, is it my favorite food or not? And I make a confirmation. Okay, these are the transactions that I have made. And it's already complete. And this one is in this activity, there are the transaction that is pending. So this transaction has not been committed yet. But this transaction is within the pool. As you can see, this one, pool, and it will be generate a random time queue. You can see it, random time queue. So these are generated by the cloud function. This one, cloud function. I will demonstrate you more. To see how does it work or something like that. Okay, and these are our nodes. We have 3 nodes called Zeus in Japan region. I put the region Japan, Babylon, Singapore, and Apollo is in Hong Kong. So if the transaction has not yet committed because I haven't restarted the instance of the nodes yet. Okay, we can see we have 3 nodes, and I will restart all these 3 and to see which one will be the one who complete the one who validate the transition. Let's start, refresh. You see the transition is start. Which one will be the one who completed first? As you can see that Zeus will be the one who completed first because this transition has minimum time. I mean less time than the other 2. When this one is complete, it will hold other 2 nodes that it will tell these 2 nodes, it will tell Apollo and Babylon that the transition already complete. You should stop the countdown. And 3, 2, 1. So this one already did this. You see, when it's add a new transition has been complete, it distributes this one to Zeus itself first, and then it distributes to Babylon and Apollo. As you can see, these are the transitions that has been complete. You can see the address. This one is all. Let's go to the database and check. This is the block transition. Sorry. Let's see which one. This one is transition. Sorry. Okay. You see this transition already complete. And let me refresh this one. And gone. My activity gone. I can see transition, food, American cheeseburger. And when I come back to home, I check my account amount. You can see it deducted. And Tommy will be the one who received that transition. Can you see? American cheeseburger. And he received another 1,000. You see? You can see? This is our model: block hash, preview hash, owner address, transition address, and create by. This create by is the node's validator hash address. Okay. And we can go to this is the address that we have. We can go to nodes and transition in Zeus. Do we have that? Yes, we also have that. We check Babylon transition. Yes, we have that transition also. And we check Apollo transition. We have that transition also. So as you can see that we have distributed. So for instance, I am the owner. I am the one who created this simulation. I want to tamper the data or delete the data. What happens? Okay, let me go to the transition that I have. This is the transition that we have, like food, American cheeseburger, receiver address, sender address, something like that. And I want to tamper the amount. Maybe I put like 5,000, something like that. What happened? When I just changed it, and then it changed it back. Why? Who did this? Who ran this? We can check the cloud function here. This cloud function here is the one who handle. It checked the transition here to see it validate or not. It knows that. You can see. You see the function here. Transition prevent changes. Amount 5,000. Because it knows that something is changed, something is wrong. The hash value is invalid, so it reinstated it back. You can see it. If I want to delete this one, delete document, I want to delete this one. What happened? You see, I already deleted it. You see, it come back. You see, it come back. Let me refresh the log. You can see the log. See, transition prevent changes. It prevents changes. It cannot be changed. It knows everything about it. Okay, so right now I want to make maybe let me go back and go to Joji, whatever. I copy his address and I come back to Tommy, and I want to make transition from Tommy to Joji, and I put like maybe 5,000. Yeah, 5,000. What is for maybe drink black tea. I put ice black tea like that, and okay, ice black tea, and I confirm. Come back to activity, ice black tea. So this transition is not yet ran, and I sign out. I go to Lex, and Lex also want to make transition to Georgia. So I'm gonna put like 8,000. Remember this 8,000. It will remove 8,000 from here. So only like 96,000 and 500 after deduct. I'm gonna make it drink also, and this one is the Americano, ice Americano. like that, confirm activity, and I want to go refresh the cloud file store. And in the pool we have two transitions. You can see that two transition. You see, two transition. After this transition is complete, it will remove it from a pool, because the cloud function will be the one who handle this one. And the queue, you can see the queue. This random time is generated by the cloud function also. I don't handle it. You can see dashboard here, cloud function. Clean queue, create queue. These are the one who handle it. And then you want to see the transition running. I can restart it. I will refresh the server and it will handle the transition. 1, 2, 3. Okay. So it seems that Zeus here will complete the transition also. Will be the one who first complete the transition. I don't know why cloud function generate the random time and Zeus always the one who gets less time. We'll see another round, the second round, after the first transition is complete. Bear with me for seconds. 3, 2, 1. So this transition is hold another 2 and start with the new transition. You can see it. It distributed already. And which one is gonna be the last time? Oh, Zeus again. It's kind of biased, to be honest. 3, 2, 1, 0. So when this the second transition has been completed and add into the block, it will hold another 2 nodes also. It will tell that it's already complete, something like that. Okay. You can see it distributed to Zeus, Babylon, and Apollo. Okay. So for instance, like these are the centralized transition and centralized block, and within the nodes we have like localized blocks and transition of nodes. This block and transition belong to the Zeus themselves, and these are blocks and transition collection belong to Babylon. So if I want to make a tamper, you know what a tamper means, right? So if I want to this is Apollo, right? And let's say I try to delete some transaction from Apollo. What happens? I delete it. You see, it just delete it, right? But let's check Apollo, this one, and I refresh it. You see, transition has been reinstated locally node. You see, it validated also. Is it true or not? It's true. Okay. So this transition I just deleted, right? Let's see. I delete this one. Transition hash, right? Let me delete this one. Okay. Let me delete this one. What happened again? You see, remove transition. You see, remove transition, and after I refresh it, it will reinstate it back. You see, because this is local nodes of instance, so the individual is the one who responsible for their blocks and transition. This stimulation does so the cloud function only handle the centralized one. It only check the validation or not, because they want to check the integrity of the blocks and transition. For instance, I want to add block document. I want to add block ID. I want to add amount, number, maybe 10,000, like that. 10,000, yes, 10,000. Whatever. I just made up whatever. For instance, this is already valid block, right? I want to add into the block. What happened? I just added, right? And then cloud function deleted because it knows that this transition is invalid. Okay, hope you all understand. You see the activity gone, transition is come, drink Americano. So my amount is deduct, you can see. These are the transition, we have it. This is like a visualization that I have, and this is the individual transition. You can check Joji, his amount has increased or not. You see, you can see sender address, receiver address. So this is Joji address, ice Americano and ice black tea, and this amount he has received, something like that. Okay, hope you all understand what is this blockchain simulation about. So it's kind of all the source code has been is a public repository. You can pull it. This is app. This app is React. This user interface, and this cloud function. You can deploy your cloud function individually, personalize it whatever you want. And this one is dBlind nodes. This dBlind node I host it in 2 EC2, and another one is on localhost. Like we have 3 instances. It's kind of easy to virtualize differently. And okay, you can see all the database that we have here. User, very basic user. We have like create ID, name, password, and username. That's it, like that. You can mark the data like me. And transitions, nodes. These are the nodes. Active, online, fall, Apollo, block. These are the block. You can see. Block, bank. Bank is like when I create the first customer, I use the bank agent to initialize the first token, the amount of token that user received. So as you can see, like the first token doesn't have the previous hash. You can see the previous hash is empty. You can see 1 million token. As you can see, the first customer has token of 1 million. Okay, hope you all like my project, and if you do like it, you can share to your friend or feel free to use any of my code that I have published it into the GitHub, my repository. Okay, good luck, and thank you for your time. Thank you for your patience to see all this video. Thank you, I appreciate that. Okay, goodbye.